Hello, everybody. Here we are, 8.1, properties of tangent to a circle. Here are just some notes. I have it printed out for you so you don't have to write it down. A line that intersects a circle at only one point is tangent to the circle. So you can imagine, it looks like it touches more than one point, but just imagine that it only touches it at exactly one point. This line will be tangent to our circle. And the point where the tangent intersects the circle is a point of tangency. So that little point that I just drew right there is our point of tangency. And some other little notes right here. The tangent radius property. So a tangent to a circle is perpendicular to the radius at the point of tangency. So some vocabulary in there. Perpendicular means two lines intersect, but they intersect at 90-degree angles. So, a lot of times lines might cross, but in order for them to be perpendicular, they have to cross at 90-degree angles. So we can tell these lines have crossed at 90-degree angles because we have that little square there, the telltale sign of a 90-degree angle. So that's perpendicular. And at the point of tangency, remember that's the one point where our tangent, this line right there, intersects with the outside of the circle, and that's perpendicular to the radius. The radius is, remember, the distance between the center of the circle to the outside. Maybe I could put that down. Radius equals to the outside. I think most of you know that. Remember, the diameter is all the way across. And so from the radius to the point of tangency, or to our tangent, intersects at a 90-degree angle. There you go. I want to point out this says angle APO. Typically, the angle that we are going to be talking about, or where to find that exact angle, is going to be the middle one. So we have APO, and it's this angle that we're talking about, is equal to angle BPO. So you notice the P's are in the middle, and they each equal 90 degrees. I really like these. I like circle geometry because it's kind of like problem solving. So I think it can kind of be fun. You use rules to solve problems. And I mean, maybe that seems fun to me and not other people, but I hope you enjoy it. Let's use some rules to solve this first question. So point O is in the center of the circle. So point O right there, we know is the center of the circle. Okay. And points P and Q right here and right here are points of tangency. Determine the value of x. So this is a mystery right there that we need to solve. And y. You can tell this is an angle of x because there's that little angle symbol there, a degree symbol. And y is going to be a length. So it's denoting a length and not a degree. So we're looking for this angle x, and we're looking for this length y. Okay, so let's use what we know to solve these mysteries. We know that the radius intersects a tangent, the point of tangency, at 90 degrees. So we know this is a 90-degree angle right there, and we know this is a 90-degree angle right there. Okay, and what else do we know? So maybe I'll say, I could type this out. What we know. Let's see, the radius meets with the tangent at 90 degrees. Where's the degree button? Degrees, there we go. What else do we know? We know also that, there we go. Seeing it in real time. There we go. That the angles inside a triangle equal 180 degrees. Okay, so let's use that second piece of information that I wrote down. So I know that the angles inside a triangle equal 180 degrees. So how can that be helpful for us? We know this one is 90, this one is marked off as 23, and so we can use that information to find x. We can say that 180 degrees are total minus the 90 degrees and minus the 23 degrees will equal x degrees. So let me use my calculator. We've got 180 minus 90 minus 23 equals 67 degrees. Okay, so you can label that if you'd like. And then we need to solve for y. So what else do we need to know? Or what else do we know? Let's see, maybe I'll keep on typing. Let's go here. I'll type down here. We know that the radius is 5. Doesn't say what units or anything, but we know that, this is a radius right here. We know this is a radius right here, so we know those two are equal. What else do we know? We know these are both right triangles, and I would say we know that our two triangles share a hypotenuse. Okay, so why does that help us? Well, here we go. We know that these two sides are equal length. They're both the radius, so they're both 5. We know that they share the hypotenuse. The hypotenuse is always opposite our 90-degree angle. And so what does that mean? That means based on the Pythagorean theorem that, a squared, maybe I should say this is another thing that we know. We also know that can I do a squared in this? I don't think so. Squared plus b squared equals c squared. And we can use that information to deduce from this that y has to be 12. That if this is 5 and this is 5, and they share a hypotenuse, it has to be true that 5 squared plus 12 squared is going to equal our hypotenuse. So it also has to be true that this needs to be 5 and this would have to be 12 in order for that to equal the same hypotenuse. So I think we can, without even really kind of solving anything, without even using the Pythagorean theorem, we can be sure that y equals 12. So I like these problems because one of the things I'm supposed to assess you on is logic and reasoning. And you could use the Pythagorean theorem to find this certainly. But I think because these things are true, we can know for certain this is 12. Okay, let's do the next one. So point O is the center of the circle right there. Point P is a point of tangency. So what do we know? We know that that is a right angle right there, and that's 90 degrees. Determine the value of x to the nearest tenth. So we need that value right there. So what do we know? We know that this is a right triangle, and so we can use the Pythagorean theorem that a squared plus b squared equals c squared to find out the length of x. So we have a 5. We have 5 squared plus, this is called a leg. This is a leg, and this is the hypotenuse. The hypotenuse is always the longest side, and it's always adjacent or across from our 90-degree angle. So it's the b squared that we don't know, but we do know that that's going to equal 11 squared. So let's continue to solve this. 5 squared is 25. B squared is, we still don't know, and that's going to equal 121, which is 11 squared. And now we need to isolate our B. So let's minus 25 from each side. And we are going to get that 121 minus 25. B squared equals 96. And if you remember from grade 8, our last step here to get rid of the squared, we can do the inverse operation. So we can take the square root of each of these, and that would kind of like cancel this out. And so we'll be left with b equals the square root of 96. How do I do this on this calculator? 96 square root. There we go. Let's do 9.8. So b equals 9.8. Doesn't say which units. And as a final step, sorry, I have a little cold. As a final step, we should ask ourselves, does this make sense? I would say this makes sense. Our hypotenuse needs to be the longest length. 9.8 seems reasonable. Seems longer than the 5, but it's not more than our hypotenuse. And it's pretty close to it, so I would say that makes sense. Let's do our last question. A wheel has a radius of 30 centimeters. Okay, so what do we know about that? We know that from here to here is going to be 30 centimeters. We also know from here to here is 30 centimeters, but that might not be relevant. Certainly that one seems relevant. Let me see. It rolls along the ground towards a tack that is 58 centimeters from the point. So I guess the tack is here. They've told us this is 58 centimeters. Okay. What is the distance, d? Okay. Between the tack and the closest point on the circumference of the wheel. So some vocabulary as well. I guess this 30, this idea that this is 30 is relevant because we want to know just this section right here. So this is the circumference, the outside of our circle. They want to know what's the distance from the tack to the outside of our wheel. So we do actually need to know that that part is 30 as well. So let's use the Pythagorean theorem to find out the entire distance. So let's use it to find out this whole thing right here. And then we can minus out that 30. So let's go. We know that a squared, 30 squared, plus b squared, 58 squared, equals, well, let's do c squared. So let's do that in my calculator. Should have known that. 900 plus 58 squared, 3364 equals c squared. Let's add those two together, plus 900. So 4264 equals c squared. And often the last step in solving a question with the Pythagorean theorem is we need to take the square root of each side. That's going to cancel that guy out, and we'll be left with c equals the square root of 4264. Let me see if that'll get us there. I think that makes sense. 65.3. So c equals 65.3 centimeters. We should ask ourselves, does that make sense? I would say that makes sense. It's longer than 58, but not drastically longer or anything like that. So now we found the whole length from the center of our circle to the tack, but they want to know what's just this part right here. What's just that d distance? So we need to go 65.3 minus out the 30, our radius, and that's going to leave us with 35.3 centimeters. So there you have it. I hope you will enjoy this section and some problem solving. I'll let you know what textbook questions I'd like you to do.